In this video, we'll talk about Taylor series. So the definition of Taylor and Maclaurin series for a function. Suppose the function f has derivatives of all orders on an interval containing the point a, like the first derivative, the second derivative, the third, and so on, exist. The Taylor series for f centered at a is given by f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial x minus a squared plus the third derivative of f with respect to of a over 3 factorial x minus a cubed plus and so on, which can be actually compressed into sum as k equals 0 to infinity of the k derivative of f of a over k factorial x minus a to the k. Now, something very important is a Taylor series centered at 0, it's called a Maclaurin series. So basically, if everywhere you see a, you actually put a 0, then you are calculating a Maclaurin series. So let's do this example. Find the first 4 non-zero terms of the Taylor series for the given function centered at a. B, write the power series using summation notation. The function is f of x equals sine of x, and the point a, it's pi over 2. So, we want to do the Taylor series. So we know, if we take a look at the formula, that we need f of pi over 2, which is sine of pi over 2, which is equal to 1. Then we need the first derivative. So I'm going to calculate f prime of x, it's cosine of x, and f prime of pi over 2, it's cosine of pi over 2, which is 0. F double prime of x is negative sine of x, which gives us f double prime of pi over 2 is negative sine of pi over 2, which is negative 1. We want the first 4 non-zero, so I have one term, 2, so I have to do a few more derivatives. The third derivative of x is negative cosine of x, so f triple prime of pi over 2, it's equal to negative cosine of pi over 2, which is 0. F the fourth derivative of x equals sine of x, and so f the fourth derivative of pi over 2 is equal to sine of pi over 2, which is equal to 1. So I actually have 1, 2, 3 terms. So I have to do more derivatives. Cosine of x, this is going to produce again a 0. And the sixth derivative of x is negative sine of x. And so the sixth derivative of f at pi over 2 is negative 1. So I have actually 4 terms. So now, what does that mean? It means that our Taylor series can be written f of pi over 2, so that's 1. So I have, so that's 1, plus the first derivative, that's 0. The second derivative is negative 1 over 2 factorial, x minus pi over 2 to the second. Then the third derivative is 0, so the fourth derivative plus 1 over 4 factorial, x minus pi over 2 to the fourth, plus the fifth derivative is 0, the sixth derivative, so it's plus negative 1 over 6 factorial, x minus pi over 2 to the 6th, and so on. So this would be the Taylor series with 4 terms. Now write the power series using summation notation, so I can actually write the Taylor series. It's equal to sum as, so I have to try to make a connection, 1, 4, 6, I also have minus, plus, so it's alternating, negative 1 to the, let's see, k, and then over, or times x minus pi over 2 to the k, and over, so I have 2 factorial, 4 factorial, 6 factorial. How about we put 2k factorial, and we put, here we put 2k, so because the exponents are also even, and I want the first term to be 1. So if k equals 0 to infinity, if k equals 0, we get -1 to 0, that's 1, 0 factorial, that's 1, and then x minus pi over 2 to 0, that's 1 as well. So we get the first term. If k equals 1, we get -1 over 2 factorial, x minus pi over 2 to the 2, and so you can check the other ones, but we actually got the 4 terms, and we also wrote the Taylor series in summation form. Let's look at another problem. Use the Taylor series table to find the first 4 non-zero terms of the Taylor series for the function centered at 0. Well, let's not use the table. Let's actually try to calculate this ourselves. Or actually, because the derivatives are pretty complicated, let's use the table. From the table, I wrote that ln of 1 plus x can be written as a Taylor series centered at 0, as a Maclaurin series, the way you see here. So these are the terms, and then the summation notation where x is between 1 and -1, including 1. So in our case, our function looks like the one that I have here, only the term in x, right? Here it's x squared and here it's x. So our Taylor series will change a little bit. So ln of 1 plus x squared is going to be, everywhere I see x, I'm going to put x squared. So that's going to make it x squared minus x to the 4th over 2 plus x to the 6th over 3 minus x to the 8 over 4 plus plus -1 to k plus 1 x to 2k over k equals sum as k equals 1 to infinity -1 to k plus 1 x to 2k over k. So basically we got more than just 4 terms, but if I were to write exactly 4, I would just stop here.